We're going to be taking a look at problems 1, 2, 3, and 4 on the equilibrium practice problems. In number 1, this object, 7 kilograms, is not moving at all. Upward, we're going to have the normal force. Downward, we're going to have the force of gravity. And because there's no acceleration, when we say up minus down equals ma, which is Newton's second law, we can ultimately just say that up equals down, as we can do for all these problems. So up equals down, normal equals force of gravity. Force of gravity is mass times 9.8, so 7 times 9.8. Tells me that the normal force is 68.6 newtons. For number 2, a little bit bigger, normal up, gravity down for this object. It's moving at a constant speed to the right, but there's no pushing force. It's just sliding. It could be rolling, whatever. But force of gravity down and normal force up. Again, there's no acceleration, so what that means is up equals down. So normal equals force of gravity. Force of gravity is mass times g, which is 9.8. So 5 times 9.8 is 49 newtons. Number 3. In this problem, the object is being pushed to the right with a force of 20 newtons. The forces that aren't given, but you have to know that are there, are force of gravity down, normal force up, force of friction left. Up stuff is going to equal down stuff, as always, because A equals 0, and right's going to equal left, because, again, there is no acceleration. So when up equals down, our normal force equals force of gravity. Force of gravity is the mass times 9.8. So 9 times 9.8 tells us the normal force is 88.2 newtons. Right and left, our right arrow is force of push, left arrow force of friction. So force of push equals force of friction, and since force of push is given at 20, we know force of friction is also 20 newtons. Number 4, tension is up, force of gravity is down. You're pulling on the rope. Since it's one piece of rope, the tension and the force of pull are going to be identical, and so we are going to be able to figure out, because of the mass of this thing, we would be able to find force of gravity, and up equals down. So we're trying to find that tension in the rope. And up equals down, tension equals force of gravity. So 2 times 9.8 is 19.6. And again, one piece of rope. So the tension in the rope must be how much you're pulling. So you're pulling with a force of 19.6 newtons.